What's going on, guys? I want to try to make a relatively quick video here to answer this question that I recently received on my making a slip joint part 11 video on my slip joint build series. And this is where I talked about setting the rise and fall, kind of getting your tension dialed in, etc. And the question here was, he says, I'm struggling to get the pivot point right. I want it flush in all positions, which he's talking about open, closed, and half stop. And a real snap when I open or close it. I love your vids, but you left out the most important part. The geometry while designing the pivot point. Are all angles 90 degrees? Is the top the same as the bottom? How do you make sure the knife can snap shut without touching the back spring? What makes it snap in position? So on and so forth. So first thing I'll answer before we kind of get into the geometry, the snap of the knife all has to do with your spring tension and setting that tension. I believe I do talk about that in, I think, a following video. I forget what I had titled it now, probably the 12th one, or there's one that I think I remade because it was kind of blurry. But basically, you kind of preset that tension based on either the shape of your back spring or by moving your pin locations or kicking it forward a little bit. There's a few videos and some write-ups on that on YouTube and various other forums, and because I'm kind of limited to only 15 minutes here for YouTube, I can't really get into that other than just to say that you preset the tension. I tend to start a little on the heavier side, and then I remove material from the middle of the spring to kind of dial it in to exactly where I want it. Obviously you want to try to get it somewhat close the first time, and then you can remove material from the spring, thin it out to lessen that tension. But that's really all you have to do for that snap. You set the tension of the spring, and that gives you your snap open and shut. Now, to get on to the geometry as quickly as we can here, we're kind of assuming that you've already got close to a final knife design and that you've got a blade shape, handle shape, and then kind of have your final dimensions roughly in place. Now, obviously, everything kind of plays off one another. Your blade size will play off your handle size, your spring thickness, tang size. It all kind of ties into one another to kind of make the whole. So you do kind of have to consider all these parts, but assuming you're relatively close to a functional design, all of this can kind of be tweaked on the fly, especially if you're in a CAD program, which most of my knife designs, at least folders, slip joints, liner locks, etc., do usually end up into a CAD program just because it is so easy to then make final adjustments, scale things, change dimensions, and then print things for templates. You can do this all on paper or even just directly on the steel itself, but it's really so much easier to get close to where your final product's going to be if you start in a CAD program. And for that, I recommend DraftSight. It's free, it's very feature-rich, does everything you could want it to and more, and there's lots of help on forums and YouTube. If you've got any questions on any part of it, it's pretty easy to figure out that way, in my opinion. So get your design into CAD. It is worth the hassle, it's worth the effort, and you kind of see that as we go along here. So now to get to the rest of the question, how do you get your flush positions, open, close, half stop? How do you establish your angles here? How do you know what to do? Again, everything kind of ties off, other aspects around itself. So I'm going to try to kind of get through this. And again, understanding this is also a finalized design, more or less. There's not going to be a whole lot of tweaking to do. But hopefully you kind of get the point. And where I like to start is in the open position. We've already established, again, our blade and handle sizes and shape, roughly. Again, and I can tweak this, in or out. I can make this a little bit wider this way, deeper this way. I could change it all over the place. I'm not going to here. Just because, again, I've already kind of finalized this design. But now we're kind of at the point as to where we want our blade to open and close and half stop without moving the relative position of the spring. So in order to do that, again, you start in the open position. You've already established your pivot point roughly. Go from the center and take the diameter of that circle right to the edge of that back spring. And that pretty much sets your 3 points. So open, half stop, closed. Those are your 3 points. And you can see the circle goes past the tang here. You'll see why in a minute. This is concave. So if we did take a straight line from the 2 extreme points there, it would be tangential as well, or right in line with those 3 points. So just to kind of show you the half closed position, or the half stop, we're gonna, first we're gonna click on the right thing, click on our blade, and then rotate relative to the center of the pivot. So this is roughly our half stop here, and you can see that's a pretty good half stop. It looks like it's about 90 degrees. Actually, the angle on that tang is 95. If you want to take my word for it. If not, I guess I can dimension that real quick. So if we go here, you can see that's 95 degrees from this line to this line. I think anywhere between 85 and 95 is a pretty good half stop. There's no hard set rules there. Most guys do around 90, give or take. But there's some play there if you want to open it or close it just a little bit more. Just kind of do what looks good to you. Obviously if our half stop ends up right there, that's probably a little too closed. If it ends up there, that's probably a little too open. Again, you've got probably 5 or 10 degrees there that you can play around with and still make it look good. So again, that circle basically sets the bottom of our tang limit, which gives us a half stop position that will not raise or lower that spring away from the flush position. And that angle here, as far as how much that's pivoted relative to your back spring, again, 85 to 95 degrees, that's really up to you. I could move this out, move this in, just as long as I'm keeping that tangent point the same. My half stop will keep a flush back spring. So hopefully that kind of explains that. Now kind of quickly moving on to this point, because it is concave, the circle does look like it's going past it a little bit. But if we take a straight line from the contact points, or each end of that concave curve, you can see it does touch right against the tangent of that circle once again. So kind of imagine this is your back spring. These are going to be the 2 points contacting that back spring. And, again, I can move this tang in or out, but then I'd have to move this the opposite to compensate, just to keep that tangent point. You can move it around, you can play with it, and really do just about whatever you want, as long as this part, which is what contacts the back spring in the closed position, as long as that's the same distance at the point that it intersects your circle from the pivot there, as long as that's touching the same, this is the same, this is the same, you're going to be flush in those 3 positions, pretty much guaranteed. Now, as far as keeping your edge from contacting the back spring or getting your point in the right spot, again, let's go ahead and rotate. So it's theoretically going to close to about right there. We're touching here, we're touching here. And as you can see, there is a good gap along our edge. Our point is concealed. But again, if you don't like how this is, I mean, I could change my dimension of my back spring right now. I could change the dimension of my edge right now. I can move my point in, up, left, right, make my handle thicker. You know, all that can be done in CAD right now. And then once that's done, I can then kind of open my blade back to the half stop position, see what it looks like, or back to the open position, you know, give or take, see what that looks like. And you know, that's what's nice again about having everything in CAD. You can kind of make all your adjustments on the fly and get everything dialed in really nice and precisely. And you know, that's going to give you your general idea of where things are going to be, or if it's possible to get a flush back spring in those positions. Now, one thing I will mention, when I print this out, I'll separate the blade, the handle, the back spring, all into separate parts. And when I'm cutting this out on the bandsaw, shaping it, you know, I'll grind right up to these lines, because those aren't as critical. But around the tang, the pivot, and all that, I'm going to be somewhat precise, but I'm still going to leave some extra meat around this area at the bottom of the tang. You know, I'll know that pretty precisely. But what that'll let me do then is to couple that with a rupel indicator or a rise and fall indicator, and then with my back spring. You know, as precise as you can get this in CAD, I'll say this. You're never going to be able to transfer that pattern, cut it out, grind it, drill it, heat treat it, and still be anywhere close to as precise as you were in that CAD drawing. So we kind of compensate by leaving extra meat, you know, where we can, using the rise and fall indicators, and then kind of putting things together, taking them apart, and going through the build process, as I kind of showed in my video series, to get the final, you know, ultimately final dimensions and fit up. But this does give you a very solid foundation, a good starting point, again, of where to put your points, your edge, you know, your tang geometry. Hopefully that all kind of makes sense. I know I kind of rushed through it. This 12.5 minutes went by really fast. I think I only get 15. So I'm probably going to stop it there. But again, just keep in mind, everything kind of runs, you know, one feature off of another. They all work together from small parts into the whole to make your final knife. And just keep that in mind. You know, if you adjust this blade longer, you have to make the handle longer. If the tang's wider or you move the pivot, you've got to adjust the width or length of your handle there. You know, this end I can make round, flat, long, skinny, any number of changes I can make, and that's kind of where you get all your different patterns from. You know, just one guy wanted one part a little wider or longer than the other. Maybe he wanted a sharper curve here, shallower there, and you know, ultimately it just kind of morphs into a whole different slip joint design. And that's the great thing about all these patterns and slip joints is you know, you can kind of make whatever you want, however you want, and as long as it looks good to you, you know, once you kind of get towards that final point, you know, that's where you can really dial it in and you know, flush up your back springs, get your points and edges where you want them, the shapes of your springs, etc. So I really hope that helps. If there's anything I could maybe clarify, by all means leave a comment below and I'll try to get to it or maybe make a better video. But again, hopefully that gives you a starting point, and you can kind of go from there and understand the process behind getting everything fitting together just right. So thanks for watching. Again, I hope that helps, and we'll see you on the next one.